Something that we lose when we convert from a Lewis structure to a bond-line structure is the number of hydrogen atoms that we have in a molecule. Because of that, it's very important to be able to interpret formal charges with bond-line structures. Okay, so let's take an example of a carbocation right here, where the carbon atom has a positive charge. What does that mean? Well, typically, if we just had this molecule here, we would have two extra hydrogen atoms. These hydrogen atoms result from a bond, basically sharing of two electrons between the carbon and the hydrogen. If the carbon atom loses one of its electrons, it can't make this extra bond here. Essentially, we have only a single hydrogen here and a positive charge. Whenever you have a positive charge on a carbon atom, you're losing one of the bonds. It's only making 3 bonds. In this case, we have a carbanion. A negative charge means we have an extra electron on the molecule. This is a case where we can use that shortcut. Carbon typically makes 4 bonds. In this case, we have -1 formal charge, so it's only making 3 bonds, which means we've got a lone pair. So in this case here, again we have a single hydrogen atom, but we also have a lone pair with that extra negative charge coming right here. Okay, let's take a heteroatom, oxygen, in this case O-. How many bonds is that going to make? We're going to use the shortcut again. Oxygen typically makes 2 bonds. In this case, it has a -1 charge. It's only making 1 bond. So there are no hydrogens here. We would have to draw them anyway because it's a heteroatom. But for this oxygen atom to have 8 valence electrons, we get 2 from this bond here, 4, 6, 8. One more example, N-. Again, we can use the shortcut. Nitrogen typically makes 3 bonds. In this case, -1 means it's going to be making 2 bonds. We already have 2 bonds right here, which means the other 8 electrons have to be coming from lone pairs. So if we redraw this, lone pair here, lone pair here, we are now satisfying the octet rule. We have a negative charge. We can think back just to a Lewis structure of nitrogen. If we have nitrogen normally, it has 5 valence electrons. We have an extra negative charge here. That's going to pair up one of these unpaired electrons, and now we have 2 lone pairs, and we can also make 2 bonds with the formal negative charge.